Hey, welcome everyone to the Xpu session. Just one thing to mention, you want to click the little bell icon above to turn off your notifications. So my name is Oliver Meisberg. I'm the VP for the RenderMan group at Pixar. And in a few seconds, I will bring up the Xpu team from the development side, from the RenderMan team, but also Alec Barch from production, who is using Xpu for quite some time. And he will show you Xpu in our internal look dev tool Flow and share some of his experiences. And then from the RenderMan team, we will have Max, Fran, and Lucy talk about the latest advancements of Xpu. And as you might have heard in previous sessions already, so Xpu will finally make its way out. And it will be part of the RenderMan 24 release. And we start the beta cycle in December this year, and we're going to ship Xpu in Q1 2021. So without further ado, I want to bring up on stage Lucy, Max, and Fran from the RenderMan team to give you the latest updates on Xpu.
Thanks, Oliver. So I'm Lucy, and with my colleagues Max and Fran and Alec, I'm just going to give you an overview of where we are with Xpu development. So first of all, I'm just going to give a quick overview of the last year and what our focus has been. Then I'll hand over to Fran, who's going to tell you a bit more about the latest developments with image quality. Max is going to talk about our performance work, and then I'll just come back to tell you what the next steps are for Xpu, and then we'll hand over to Alec Barch, who's going to give a demo. So where are we with Xpu? And first of all, what is it? I imagine that most of you are here because you've heard of Xpu before and you want to know where we are, but just in case you haven't, it's a new heterogeneous renderer which has been designed to make the most of the available hardware, whether it's running on an artist's workstation or on the render farm. So it can run on the CPU, the GPU, or it can use both at once. And all of those combinations will give you perceptually similar results. Its design enables it to make the most of the parallel capabilities of today's hardware. And it's also been designed very much with future hardware in mind, so it can be easily extended to support new devices. During the last year, our focus has been on integrating Xpu into Pixar's Flow tool, which is used internally for look development. And Xpu is intended there to be a replacement to RTP, which is an existing GPU renderer used for interactive preview. And the advantage of Xpu over RTP is that it produces results which are visually very similar to those of RIS, RenderMan's current renderer. So artists can switch in Flow between using Xpu and RIS now. And the eventual goal is that Xpu will replace RIS once we've implemented all the features that are required. So this focus on Flow and Xpu for look development has really helped to inform our development priorities this year and helped us to turn Xpu from an interesting prototype into a production-ready renderer. So obviously, stability has been key when we're getting a new renderer into the hands of artists. And we've also spent many hours of effort ensuring a close visual match between Xpu and RIS. And one of the areas of focus for performance has been that artists need a fast response time when they're making interactive edits, and that's really driven a lot of the feedback we've been getting from the Flow team. So alongside the integration into Flow, we're continuing to work towards the long-term goals for Xpu. So we're continually reviewing the architecture and design decisions that we've made to ensure that we have a firm foundation for future development as we continue to add more features and improve the renderer. We're prioritizing feature requests based on feedback that we're now beginning to get from artists. We've also been working closely with hardware partners on performance, and Max is going to tell you a bit more about that work. And then in addition, we've been targeting increasingly complex production scenes, and I'm now going to hand over to Fran, who will tell you a bit more about that.
Perfect. So thank you, Lucy. First of all, hi, everyone. It's really nice to be here with all of you virtually. And I'm Fran Gonzalez, a senior software engineer in the RenderMan team at Pixar. And today, I'm going to show you how Xpu performs with respect to image quality against RenderMan RES. So first of all, the first important message that we would like to send to you guys is that at the moment that you get your hands on Xpu for first time, you're going to see it by yourself that Xpu is completely ready to handle complex production assets in the most efficient way. During last year Art and Science Fair, we already showed it to you that Xpu was already capable at that moment in time to handle geometric complexity. From the huge Moana Island from the Walt Disney Animation Studios up to the rich and detailed scene that we are showing here rendered with Xpu from our film Coco, this train station. And we even demonstrated that Xpu was already capable at that moment in time to render different type of geometric primitives like fur, hair, and even particles, like the one shown here in this render, done again with RenderMan Xpu from the film Incredible Zoo. So given the shift that we have done during the last year to focus with RenderMan Xpu more on the look depth, all the team has been putting a lot of effort and a lot of work to provide to Xpu with a shading system that is capable to handle shading complexity besides the the geometric complexity that we already showed to you last year. Let me give you an example of what I mean by shading complexity. So here you can see the render of Parley. He's one of the main characters from our latest movie, Onward. And this render has been generated with RenderMan Xpu. And let me show you a few of the shading networks that the artists at Pixar created to shade Barley. Here you can see the shading network used for the jacket of Barley, the patches on the jacket, and even the shading network used to shade the skin of Barley. And as you can really tell, even those images are pretty small, those shading networks are pretty complex. Let me give you a few more numbers. To shade Barley, the artists at Pixar use more than 3,500 pattern nodes. And they use more than 150 different materials. It means that for all those 150 different materials, the input for those parameters, for those materials, come from the execution of those 3,500 pattern nodes. So as you can guess, this is quite a complex stuff and a lot of things to do at runtime. And just in case I didn't sell you the idea of shading complexity and that Xpu is going to be able to handle this, just a close view to the shading network used for the patches, and you can really tell that this is quite a lot of things to execute at runtime. And it means that every time a pixel has to shade part of a patch on the jacket of Barley, it needs to execute many times this shading network. So a lot of things are happening there. So this is quite a lot of computations. So now that I have shown you that Xpu is going to be capable to handle both geometric complexity plus shading complexity, is going to be completely ready for that, I would like to show you how Xpu is going to compare with respect to image quality to RenderMan RES. So here on the left side of the slide, you can see the render of Barley, rendered with RenderMan RES. And as you can expect, it has a high quality one would expect from the engine. Just right next to it, you can see exactly the same render, but render with RenderMan Xpu using its CPU variant. It means that we have used just the CPU to generate this image. And next to the CPU render, we can see exactly the same GPU render using Xpu. So it means that we have used just the GPU in our workstation. And finally, of course, here you have the combined render in which we are showing you the combined results of allowing both devices to combine to the final render. And as you can clearly see, there are no difference. It's really difficult to spot any difference on those 4 different renders. And believe me, there are 4 different renders. We are not cheating you. And of course, there will be some differences, but the differences will mostly come from the fact that we are executing the render in different devices. So the differences are going to represent numerical precision differences. Let me show you another asset, another example to compare RenderMan XPU and RenderMan RIS. Here you can see the band that Barley drives through most of the film. Sorry for the spoilers. And this is quite a complex asset as well. It has a lot of shading networks, geometry is quite complex. And next to it, you can see the exact same result as rendered with RenderMan using its CPU variant. And it's really difficult, again, to spot any real difference. Here you can see the same render generated with XPU GPU variant. And again, if I go back and forth, not perceptible difference. And finally, the combined render to compare RenderMan RIS and XPU CPU plus GPU. So let me show you the 4 renders in just one single slide. And one would say that this slide is quite boring, and somehow I agree. But this is also showing to you that you are going to be able to expect RenderMan XPU to be predictable no matter what device you use for rendering your scenes and your assets. And that RenderMan XPU is going to be also predictable with respect to RenderMan RIS, which is going to be a good thing as well, because you're going to be doing your look depth with RenderMan XPU super fast, and then you can shift to your final production shot with RenderMan RIS. So now I'm going to hand it off to Max, and he's going to talk to you more about XPU and its performance.
Thanks, Ren. For people that don't know me, I'm Max Liani. I'm one of the lead engineers for RenderMan, and I've been working on XPU since the beginning. One of the key aspects of XPU is clearly performance. We want to enable you to render interactively and closest to real-time as possible, although we are not aiming to real-time rendering. This is not a real-time engine. It's aimed for final frame production for movies. So over the years, we collaborated with our partners, Intel and Nvidia. The collaboration with Intel is something that we worked together on optimizing the existing render, the RIS render, for quite some time. And RIS, as was described like in previous session, is a very powerful and versatile architecture. It's one of the few batched renderers that you can find in the commercial side of the render engine spectrum. The thing that we noticed is how difficult it was to really truly optimize. And this histogram show, for example, rendering this asset, which is not quite as complex as Barley or the van that Fran showed. Still, it is shaded procedurally with probably like about 30 nodes with lots of noise, procedural noises. So it's not a trivial asset from a computational perspective. Trying to optimize RIS to leverage SIMD execution on the CPU produced only a modest speed up, and we thought we could do better. So when we started on the journey to implement XPU, we started from a blank canvas and created a brand new architecture. And it's an architecture that is based on a data parallel design and wavefront rendering, which is more SIMD friendly and can scale well to modern instruction set. So this shows some of the work where we're not comparing CPU and GPU here. We're comparing a two generation of rendering architecture, rendering on the very same hardware, in this case a CPU, rendering the very same image, which looks exactly the same. And out of the bat, XPU on the CPU is substantially faster than the existing architecture. Not only, when we apply the same type of optimization effort and techniques to the new code base, we get a much more substantial performance boost. So rendering this statue here, for example, on an Intel CPU with AVX512, produces close to a 4x speed up on the very same CPU. So let's say that you have your render farm, which you purchased last year. You have a hardware refresh, and you want to, predict how much XPU will perform on your existing hardware, which you have to, amortize over the cost of the next few years. And this type of figures is the one that you are after. It's probably not the render time, because your assets and my assets, or Pixar production assets, this is my developer art. They are all different. You want to know how much faster it is compared to what you see today in your scene. And this is kind of like a reasonable prediction. Also, XPU is designed from the beginning to work on heterogeneous hardware, which means running pretty much the same code, the same implementation, the same algorithms to some extent across different devices. And the CPU in our architecture is a device, as well as the GPU is. And so this is on this scene when we throw at the GPU. And in this case, these measurements were on my workstation, which is a 44 core compared to an RTX 6000. And as it was mentioned, this natural device abstraction will make it possible in the near future to support other hardware and new hardware as it comes along, and as it becomes a priority for us to support it. So moving to more production grade assets, which are texture heavy, perhaps a fair amount of PTEX and texture atlases, and that changes the performance characteristics. So here comparing as a baseline our RIS versus XPU on the very same CPU. This is running on the typical artist workstation at the studio, which is a 24-core workstation and an Nvidia Quadro RTX 6000. And you can see that scene by scene, I'm going to show you a few more after this, the performance gap between RIS and XPU on the CPU and GPU or combined kind of goes up and down depending on what type of features and what type of compute each scene exercises. But consistently, we get a substantial higher performance compared to the existing RenderMan. So here's about 4.3x on the very same CPU, and 9x on XPU. In this case, CPU and GPU combined. And result is the same. A different asset. This is the van, Guinevere. It's a complex asset. There is a lot of PTEX because it's not just a prop. It's also an environment. There are scenes that are really shot inside the van, and this is not just exterior. There is everything inside. We get a substantial boost on the very same CPU when we throw both CPU and GPU together. The performance is much more pronounced. And again, this is a third asset. This is a piece of an environment. This is the magic fountain. Well, I'm probably not called magic fountain. Let's call it the fountain in Onward. And again, we see close to 3x speed up on the very same CPU, and in this case, about a 6x, a good 6x improvement of CPU and GPU combined. So with this, passing back to Lucy to talk about the next steps.
Thank you, Max. So as Oliver mentioned at the beginning, you will be able to get your hands on XPU very soon. So we are aiming to release this with RenderMan 24. There will be a beta in December, and the release is planned for Q1 next year. So for the first release, the focus is on look development. So it's what's currently being tested in Studio in Flow, but made available in the other DCCs that we support. So in the meantime, we're continuing to test this at the studio and respond to the artist's feedback. And we're looking forward to making this available to our customers and starting to incorporate your feedback very soon. I just wanted to mention, or rather show the names of some of the people involved, because this really has been a massive team effort across all 3 of our development sites. And it's always dangerous to put up a slide with names because I'm sure that I've missed somebody, but this just gives you an idea of the scale of the effort across the team. And with that, I'm going to hand over to Alec to show you XPU in Flow.
Thanks, Lucy. Hi, everyone. Thanks for coming. My name is Alec Barch. I'm a shading TD at Pixar in our sets department. And in the many years I've been at the studio, I've had a chance to really see a continuous evolution in the tools and the technology that we've used for our shading, and to see kind of the ever-expanding creative and visual reach that they provide to us. But none have been as exciting and as transformative for us as the shift to real-time shading tools within the last couple of years, even really starting with live rendering. So I'm super excited to be one of the first people at the studio who had a chance to put XPU through its paces and kind of get a glimpse of the promise of it in our shading workflows. So while I talk about that a little bit today, I'm going to give you a behind-the-scenes look at the first tool where we will be deploying XPU at the studio, which is called Flow. And Flow is a standalone app that's purpose-built for shading. And true to its name, it's designed to give shading artists a real-time feedback experience, which is qualitatively different from the kind of render, tweak, repeat, wait workflows of the past. And so our tool shading team has been hard at work on this for a couple of years now. And so it's now at the point where this is the main place where we do our straightforward asset shading for our features, like just props, sets, and characters. And because it reads and writes USD, it flows seamlessly into our Katana-based lighting pipeline, where we can continue to do additional shading work where we want to do things that are more procedural or that need more shot context. So I will bring it up for you now. Bear with me for 1 second. Okay, so what I'm going to show you here is just a typical example of kind of a production prop. This is from an upcoming feature with some sort of small to medium-sized shading networks. So you'll see here that we have anywhere from a handful of nodes to a couple dozen. And as you saw in the earlier presentation, we certainly have assets that can go up into the hundreds of nodes, and we scale up to that. So Flow basically is a tool designed for building these networks, binding them to our assets, and seeing the results in our render viewer. And at Pixar, we rely a lot on proceduralism in our approach to shading, particularly in the sets department, but also in characters to some degree. And so we have a large complement of pattern nodes that we can use to build networks that are reusable and versatile, and that can hold up at a wide variety of different scales. So we see a glimpse of that here. So now we're in the render viewer, which is a Hydra viewer. So any Hydra delegate can be launched here. And we're going to start in RAS mode just to give you a kind of a point of reference. So this will feel familiar to you if you're used to live rendering in, say, Katana. And it's still pretty fast, but you can see that the spiral buckets are kind of chasing our camera move, and it takes a few visible iterations before we get to the point where we can make a creative decision about what we're seeing. And Now I will switch over to the to XPU, which is super exciting. And you'll see a new pop-up menu appear, which lets you choose the architecture. This is probably a choice that we will leave exposed to artists because there will be cases where certain assets will perform better on different combinations of hardware. So that'll likely be a choice that's available. And the most important takeaway from this is that as you've heard, the visual results are identical or perceptually identical to RIS. And we're now getting coherent frames back, and it's probably a little bit hard to tell over this platform, but the convergence is almost instantaneous. So you can make very rapid decisions on what you're seeing and kind of get nice fluid feedback. So here we can kind of position our specular highlight just the way we want if we were working on kind of dialing in the details of that part of the shader. And so now I'll just show you a couple of the features of the app. Right now we're isolating different illum lobes, which is a very helpful thing when you're developing a look and you just kind of want to judge what contribution you're getting from each lobe in your surface shader. And it's very important for us to be able to dive into our networks. And so if we hover over a node and hit a keyboard shortcut, Flow will create a visualizer on the fly so you can see the contribution of the network at that point. This particular asset is kind of a mix of some PTEX patterns and some straight up like fractal procedurals and things like that. So this is an example of the PTEX pattern that was created procedurally, and here's one that was painted. And so this is where a real-time workflow is just so transformative and so much fun for shading artists, because we can tweak parameters on the fly. With the previous kind of render, tweak, repeat approach, you guess, you render, you wait, you guess again, and you're never quite sure if the exact setting you wanted was the one right in between. And here's yet another PTEX pass that was generated procedurally in a different tool. And here I will show you that we can view the network at one point. We can visualize it at one point and tweak parameters upstream of that and see the result downstream. So this is yet another super important feature. This is kind of the bread and butter of what shading TDs do as they're making the hundreds of creative decisions they need to develop a look. And so, yeah. And now I think we're going to switch to a lit version again, so we can tweak a few limb parameters just to see what that looks like. So, yeah, so now we're back to a full illuminated render. And this particular asset doesn't have any displacement on it, but I will just mention that that is another thing that we can now preview changes to displacement height in real time, which is really exciting that we haven't had in our toolset before. And so here I'll just tweak the bump a little bit. And again, it's probably hard to see on this platform the kind of the detail. And then I'll do a couple of illum tweaks just to show, what that looks like to see how rapidly we can develop looks. And so that's kind of all I've got for the demo. I would just say in conclusion that like the two things that are really huge for us as far as the studio goes is that as Lucy mentioned, in previous iterations of this tool, we had a proprietary GPU-based path tracer called RTP, which relied on these nodes being written twice, once in OSL and once directly for the GPU. And so now it's all OSL for both renderers, which both lowers the barrier of entry for people who want to write new nodes, and also goes a long way towards this guarantee of very close perceptual fidelity between the two renderers. So we can really rely on this as a look dev tool and feel very confident that what we're seeing here is what we're going to be seeing in RIS. And I think the last thing I'll just show you, or I'll mention that we're also using RIS lights here. So this is our typical workflow at the studios that we'll have domes set up for us by the lighting department so that we can be shading in a context that allows us to see how the shaders behave in different lighting scenarios, but are also sanity checked so that we know that they'll behave well in actual shot lighting. So that's kind of just showing showing what that looks like. And I hope that was interesting, and I will hand it back now to Oliver. Thank you very much.
Great. Thank you, Lucy, Max, Fran, and Alec. That was really impressive. We have roughly 15 minutes to answer your questions. So feel free to drop them in the questions tab, and we'll try to go through as many as we can. So a question that came up quite often, even during previous talks, is the minimum requirements of Xpu. So Max, maybe you can answer those questions. What is the hardware?
Yeah, absolutely. So
should have
the Xpu compatibility on the CPU is pretty extended because it just runs on any CPU that any regular CPU you will run production on, let's say. On the GPU side, we limited our backward compatibility to the Maxwell, the Nvidia Maxwell architecture, which matches pretty much with the GTX 900 series, although we do indeed recommend Quadro cards and more recent because there have been like improvements, like huge performance improvements in recent years. So I would definitely recommend at minimum a Pascal or an RTX or whatever newer will come available.
Thank you. The next one's for Fran. The question is there a guideline on what kind of assets are fast on CPU versus fast on GPU?
So I have to say that
as
Mac
CPU,
already showed it to you in the presentation. What we have consistently seen is that most of the, because how Xpu has been designed, we always see Xpu GPU outperforming Xpu CPU in like most of the assets, no matter how complex or how simple they are. Of course, you could find like a really simple asset, a really special situation in which the CPU could be, the performance of the CPU and the GPU device could be quite similar, but most of the time you're going to have Xpu GPU outperforming the Xpu CPU. And of course, Xpu CPU is going to outperform RenderMan RIS. So this is usually what we have seen and experienced in all our tests with all the assets from the studio.
Thank you. The next question is there any multi-GPU support?
So I would like to
maybe that's
say first that Xpu is designed on top of a native device abstraction, where the concept of a device can be anything that we make Xpu compatible to run on. So a CPU is a device and an Nvidia GPU is a device. So as we support multiple devices, we will be able to support multiple GPUs. Although there are some interesting observations on running on multiple GPUs where you want to perhaps share memory of multiple GPUs through NVLink. And some of those optimizations we have not completed yet. Although we've done experiments on running on multiple GPUs and got some decent results. So the multi-GPU support won't be available on the first version, but we got like good close to linear scaling on a small number of GPUs, and we tested all the way up with 16 GPUs using one of those special machine learning boxes that Nvidia sell, the Nvidia DGX2. So those were interesting experiments, but that tech is not fully optimized and ready for deployment yet. It will come along.
Cool, thanks. One for Lucy. What limitations exist in XPU that would steer someone to do final renders in RIS?
I think it's mainly a question of just missing features that we haven't implemented yet. So, I mean, if you're happy with the results, there's no reason not to use it for that. But it's just basically it's a limited feature set. We're focused on look development initially, and then yes, there's no reason not to use it, but you'll probably find that you want to continue using RIS for a while.
One for Alec. When you finish look dev in Flow and send back to Katana, Houdini, or Maya, the materials could be imported and automatically be placed over the assets with the same look as you can view it in Flow. So it's more about look consistency.
I'm not sure I quite understand the question. Is it about applying them in Katana?
Yeah, pretty much like when you export shaders from Flow and bring it back into Katana and Houdini. How well does it match?
They're the same. They're identical. It's basically we're authoring an OSL shader network in Flow, and that is what gets written out to USD, and that's what gets read into Katana. The only difference is that in Katana, we at the moment are rendering in RIS, if that answers the question. So it's all, I mean, that's kind of the beauty of USD is that it's universal.
General question. For look dev artists, what recommendations can you provide for GPU hardware from your testing with very complex scenes? Probably Max can answer that first.
I personally would recommend a Quadro RTX. They're very, very good card, and they seems they're very stable. Depending on the complexity of the assets and the amount of even texture or how many layers of texture you overlay on your shaders, you may need some amount of memory to get the best performance. So Pixar Artist Workstation has like a configure with the RTX 6000. That's the GPU I would recommend. It will run on other GPUs, and we simply have not had an opportunity to test on a whole range of non-professional GPU grade. It should run, but we haven't had an opportunity to do like benchmarks of different consumer grade hardware.
Well, there's one question I think I can assign it to myself. Is there any plan to commercially release Flow? And the answer is no. So Flow is an internal look dev tool at Pixar, and it's built around an internal pipeline. So even commercializing Flow will be a massive effort that we're not going to spend time on. So I'm sorry.
Yeah, I would echo too that like the idea is that Flow is that XPU starts off as a look dev renderer, and then as it becomes more feature complete, becomes a final frame renderer, and that's the same trajectory inside the studio that will be, I think, the one for external release as well.
What light types are going to be available in the initial release? Probably Frank can answer that.
Oh, so I think mostly the lights that people are going to use the most when you're doing look dev, like red lights, dome lights, this type of lights. So, but don't expect any fancy or like having thousands of lights working with XPU. It would work, but it would go slower, of course, because it's not still ready. We still need to do some work there. It's not that we don't know what to do, but it's that we need to just spend time there. So expect the typical setup that you have when you are doing look dev with RenderMan RAS, so you're going to have the same type of lights available for RenderMan XPU.
Another question that connects to that one is what type of geometry primitives are supported in Xpu?
So for now, we support particles, we support curves for Heron for rendering. We support subdivision surfaces, triangles, of course. So most of the type of geometric primitives that you are going to use for loop depth. So we don't support right now volumes, but we are already working hard on it. So I guess that's it. I don't know if Max wants to add something about it.
Yeah, that's right. So with curves, it is all the possible combination of curves, so ribbons and round curves with like different bases and all that. That's feature complete. What we left out are the type of primitives that are not that used in production, like quadrics, like sphere, paraboloid, or tori, or things like that. And perhaps more notably blobbies and NURBS. They're not implemented yet. So we prioritize the implementing a system that will run on a CPU, in CUDA, and through optics to be accelerated in the Nvidia hardware for this type of primitives. Further support for the more exotic type of primitives will come along, but in practice, in most DCC application, you cannot create a paraboloid. So unless you start typing a rib, which most people don't, you won't have access to those type of primitives anyway. So we thought that was like a reasonable pragmatic line where to draw to get the tech ready.
Yeah, no one has ever asked me to shade a parabola yet in my career. And as of a few months ago when I was last testing, curves were all done, if I recall. Points were on the way, and I think volumes are for a future release, if that was my recollection.
General question, is GPU RAM a limiting factor in rendering?
I'll take that one. It can be, yes. So over the past few years, we focused a lot on scaling of geometric complexity. In fact, Xpu is more efficient from a memory perspective than RIS is. We implemented novel compression techniques, and we demonstrated that we can render things like the Coco train station scene or Moana Island on a regular GPU. We implemented texture caching for texture, which is the quantity that we can really grow unbounded on a production scene. That said, you need enough memory to have a reasonable texture cache size. Otherwise, the performance of texture trashing over the PCI Express bus might affect the performance on the GPU. The nice thing about Xpu is that it's not a GPU render. And if you don't have enough memory on the GPU, it will produce your image just fine on the CPU, and it will be perfectly compatible with it. So on a production, majority of the shots are not the super crazy, landscape, to the horizon one. There are a lot of close-up and characters and interior of a room, and that will render just fine. If you run into those handful of shots that are the super complex one, like the money shot, perhaps, you can render them on the CPU. No look difference. So that's your, backward compatibility, let's say, or your natural fallback, and that will work fine. And you'll see that, like what we show in terms of performance improvement, it's already much fast on the same CPU. Is already much faster than RIS. So you get a performance boost no matter what.
Cool, thank you, Max. I think we run out of time, but I want to wrap with a couple of things. So don't forget to grab your virtual teapot. The link is in the chat box. Otherwise, go to the RenderMan Pixar website. Also, the RenderMan team currently is hiring, so we have an open position. Check out pixar.com for exact details there. And then we have other sessions coming up. So there's new production shading coming up next. And then in order to attend the session, you need to click the link next to the session on the overview page, but you have to leave this one. Thank you, everyone.
Thank you.